So in this lesson, we're going to look at the 6 basic trigonometric functions, and we're going to use them to solve right triangles. So first, make sure you understand that when we're talking about right triangles, we use the same names for specific sides of a right triangle. Opposite of the right triangle is the hypotenuse, HYP for short. Then, when we're going ahead and we're talking about one of the specific non-right angles, one of its sides is called the adjacent side, and the side that is not forming that angle is its opposite side. Opposite. So we always have to think about, in relationship to the angle, is one of the legs opposite or is it adjacent? So trigonometry basically is the study of triangles, and it's pretty old. They've been using it for a long time. Okay, and it looks at how the angles determine the side measures in right triangles. We have 6 trigonometric ratios, which is just basically the name of any two sides written as a ratio. And a trig function is a rule defined by those trig ratios. So the first one we're going to go over is the sine function. And the sine function is defined as opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse. And tangent is opposite over adjacent. And for future reference, tangent is basically the ratio of the numerators of sine over cosine. And so later on that comes up. These functions over here, cosecant, secant, and cotangent, those are just the names of what we call the reciprocal functions. And so basically if you take sine and you flip it upside down, you get hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Now, you might have seen this before, SOHCAHTOA. So I remember when I took trig, my teacher taught us a little phrase to help us remember this. Some old horse came a-hoppin' through our alley. And then another teacher taught me a different one. Later on, I'll teach you in class. Basically, it's a way to help you remember the basic sine, cosine, and tangent functions. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And if you can remember those three, and just remember which ones are the reciprocals, then it's basically what you need to know. Okay? Now, another way we can write those reciprocal functions is, because cosecant is the reciprocal of sine, it's also written 1 over sine. Secant being the reciprocal of cosine is 1 over the cosine. And cotangent would be 1 over the tangent of the angle. Now let's put them to use. Here's my angle, and I want to know its sine. So I know from SOHCAHTOA, or I just remember, sine is opposite over hypotenuse. So if I'm here, my opposite would be 12, and my hypotenuse is always going to be 13. Okay, if I want the cosine, I want adjacent over hypotenuse. So 5 is my adjacent side, and 13 is still my hypotenuse. If I want tangent, tangent, remember, is the ratio of opposite over adjacent. So if I'm right here, my 12 is my opposite, and 5 is my adjacent. So that's 12 over 5. Now, to do cosecant, secant, and cotangent, if I know the sine, I just go ahead and I reciprocate it to get cosecant, reciprocate it, cosine, to get secant, and reciprocate tangent to get the cotangent. Okay, so let's look at this one. So here's my angle. So this is my opposite, and this is my adjacent, and this is my hypotenuse. My hypotenuse isn't written, so what do we know from previous courses that can help us figure out that third side? Pythagorean theorem. A squared plus b squared equals c squared. So my legs are 6, and 6 square root of 3. And we're trying to find our hypotenuse because we don't know what it is. 36 plus 36 times 3. Add those together, which would give me 144. Take the square root, which gives me 12. So now what I know is that I have a hypotenuse that measures 12. And now I can go ahead and use, I'm not going to sing it for you, SOHCAHTOA. Okay, so sine is opposite over hypotenuse, but I got to simplify it because 6 and 12 are both divisible by 6. So that's going to give me square root of 3 over 2. And if I go ahead and I reciprocate square root of 3 over 2, I get this. But if I have a square root in the denominator, I have to rationalize it. So that would be 2, So that gives me a cosecant of 2. That gives me a cosecant of 2 square root of 3 over 3. Now, for cosine, cosine is adjacent over hypotenuse, which would be 6 over 12. But 6 over 12 is the same as 1/2. And the secant is its reciprocal, 2 over 1. Tangent is opposite over adjacent, 6 square root of 3 over 6, but 6 divided by 6 leaves us square root of 3. And then if we reciprocate that, we get 1 over the square root of 3, which must be rationalized, giving me square root of 3 over 3. Now it's pretty straightforward usually to find the trig ratios when you know all the sides or can figure out the third side. But sometimes it's a little trickier when you only know the trig ratio and are asked to find all the other trig ratios. So what I do is I start off drawing a triangle, marking my right angle, and picking one of those acute angles to be my theta. So it says tangent is 7 over 24. I know this is my opposite and this is my adjacent. So that means from here, this side is opposite, and this side is my adjacent. So now I just got to figure out what's my hypotenuse. So using the magic of the Pythagorean theorem, I get that C is 25. But really, I just memorized the triple. But you can figure it out yourself. Now, it's just the same thing that we did before. So the sine is opposite over hypotenuse. And cosecant is reciprocal. Cosine is adjacent over hypotenuse, and secant being its reciprocal. And then tangent is opposite over adjacent, with cotangent being its reciprocal. Okay, let's go ahead and look at this one, number 8. So it tells me the secant is 4. So I'm going to pick one of my angles to be theta. And I know that secant is the reciprocal of cosine. So the cosine must be 1 over 4. So cosine is adjacent over hypotenuse. So my adjacent side has to be 1, and my hypotenuse has to be 4. So to get the opposite side, I'm going to use Pythagorean theorem. So I'm going to use x for my opposite side, 1 for my adjacent side, and 4 for my hypotenuse. So I get x squared plus 1 is 16, which means x squared is 15, giving me x is the square root of 15. So now I can go ahead and do this. So I have opposite over hypotenuse for sine, and cosecant is its reciprocal, so remember we have to rationalize it. 4 square root of 15 over 15. Cosine is going to be adjacent over hypotenuse, and secant its reciprocal. We already had that, of course. Tangent is opposite over adjacent, which is square root of 15 over 1, which is just square root of 15. And cotangent is its reciprocal. And remember, we have to rationalize that. So that's going to give us square root of 15 over 15. Now, there's two triangles that are special right triangles. They come up so much that I put these exclamation marks to make sure that you know you're going to basically have to memorize these. Okay, so in case you didn't know, if we have a triangle that has a hypotenuse of 1, the side opposite the 30-degree angle is always half the hypotenuse, and the side opposite the 60 is always square root of 3 over 2 times whatever the hypotenuse is. Okay, so if we wanted to write the sign, making the denominator 1 makes it a little easier. Opposite over hypotenuse for 30 degrees would be 1/2 over 1. The cosine would be adjacent over hypotenuse, which is square root of 3 over 2 over 1. And then, of course, the tangent is opposite over adjacent. So remember, when you're doing this, you end up with 1 over the square root of 3, and when you rationalize it, it's just square root of 3 over 3. Okay, and then cosecant, secant, and cotangent are its reciprocals. 2 square root of 3 over 3 when I rationalize it, and square root of 3 is the reciprocal of 1 over the square root of 3. Okay, 60-degree angle. Look what happens. I'm skipping 45 on purpose. Now, my opposite and my adjacent are switched because now I'm talking about this angle. So this is now my opposite, and this is my adjacent, and this is still my hypotenuse. So opposite of 60 would be square root of 3 over 2 over 1. Adjacent would be the 1/2. So notice they just switched. Now, square root of 3 over 2 over 1/2 would just give us square root of 3 over 1, which is just square root of 3. Okay, now we're ready to go ahead and do our cosecant, secant, and cotangent. And again, cosecant and secant just basically switch. 2 square root of 3 over 3, 2, and tangent and cotangent basically are switched because they're reciprocals of each other. Square root of 3 over 3. Okay, again, we're going to go ahead and use the hypotenuse as 45 degrees. And in case you didn't know, that this just comes from the Pythagorean theorem, and it's pretty easy to figure out. We know that if it's a 45, 45, 90 triangle, that these two sides have to be the same, giving us 2x squared equals 1. Dividing by 2 gives us 1/2, and then we take the square root of both sides. And when we take the square root of 1 over 2, it's the same as 1 over the square root of 2, and when we rationalize it, we get square root of 2 over 2. If I'm here at 45 degrees, my sign is opposite over hypotenuse, which is just 1, leaving me square root of 2 over 2. And the cosine is actually the same thing because the angles measure the same. Tangent is square root of 2 over 2 over square root of 2 over 2, which is the same number, which gives us 1. Okay, cosecant, however, is the reciprocal of that. And remember how we got that was from rationalizing 1 over the square root of 2. So if I flip that, I get square root of 2 over 1, which is just square root of 2. And we know secant has to be the same because they're the same angle measure that we're taking the ratios of. Or I'm sorry, the sides are the same because it's a isosceles triangle. And then, of course, the reciprocal of 1 is just 1. Okay, so basically, this will be your friend in trig.